Lesson 19, the graph of a linear equation in two variables is a line. So this video, or this lesson, has kind of three parts. Part one is the proof of why this statement is true. The graph of a linear equation in two variables is a line. And honestly, the book tells teachers this, and I will tell you this, that the proof of this is very difficult. And while some of you could grasp it, and I could explain it to some of you, and if you want me to do so, I encourage you to send me a request, either via email at cowboy.lipscomb@gmail.com or straight in the notes for this video, and I will do a separate video for that proof. But otherwise, I'm not going to focus on this proof, which is very much a high school proof. Most high schoolers in Algebra 2, or even maybe up towards calculus, could begin to understand really the nuances of why, not even how to do the proof, but even why what you're proving is what you need to prove to make this a true statement, or to understand the truth of this statement. So I'm not going to bother with that. I can do it. I know how to do it, but I think will just be a waste of time. Instead, I want to focus on the other two key pieces of this lesson. One is how to graph using intercepts. Well, first I'm going to just kind of remind you of what we've done over the last 4, 5, 10 lessons, the key pieces. Then I'm going to teach you how to graph using intercepts. It's the final way that we're going to learn to graph. And then the third thing is I'm going to give you some homework help. So let's get going. Without too much further ado. Okay, here we go. All right, so again, the proof of why the graph of linear equations in two variables is a line is you're gonna show that this is what you would have to show. You have to show that any point on the graph of y equals mx plus b is a point on a given line. And then you have to turn around and say that any point on that line is a point on the graph of y equals mx plus b. In other words, you kind of have to say that any point that fits this equation, y equals, say, 2x plus 3, any point that on this graph is on this line. And then you have to turn around and say that any point that's on this line must be on the graph y equals mx plus b. And we can do this proof, but I'll do it in a separate video if anyone asks for it. Otherwise, we're going to get to some kind of fun stuff. We're just going to summarize what we've learned. And we're going to then go forward and learn some new stuff. Okay, so the first point is that each non-vertical line has a number called slope that defines the steepness. Right? So every line, whether it's this line or whether it's this line or whether it's this line, all has a number that determines slope. This might have a slope of 1. This might have a slope of, I don't know, a half. And this might have a slope of negative 2/3, about. Again, if it's positive, it goes up left to right. If it's negative, it goes down left to right. That's point one. Point number two is that if we take any 2 points that aren't straight up and down, well, let's get this out of the way for a second. If we have any 2 points that are not above each other, say, x1, y1, and here we have x2, y2, and we draw, we draw our line through those points. We can find the slope using the slope formula. We can calculate the slope by just doing our rise over our run. Or we can do the calculation, right? Because the rise is going to be the difference in these guys, y2 minus y1, over the run, which is the difference in x coordinates, x2 minus x1. And that's going to be our slope. So any 2 points can be used to find the slope of a line. Okay. So Let's get rid of all this stuff. Get rid of this stuff. Get rid of this guy. This guy. Oops. Whatever. Okay. Now, any line, if you have a line with y equals mx plus b, m is the slope of the line. So y equals negative 2x plus 4, y equals negative 1/2 x minus 6, y equals 6x plus 9. The slope of this guy is minus 2. The slope of this guy is negative 1/2, and the slope of this guy is 6. It's just that number that's the coefficient of x. That's the third thing that's key. And then the fourth thing that we learned is that if you have a point, any point that's on a line, and say that's at 2, 2, you know, whatever. And we have a slope of 3, you know, up 3 over 1, up 3 over 1, up 3 over 1. There's only one line. There's only one line that will go through this point with that slope. And so we did various kind of simple pieces of intuition around these points and kind of some understanding, a lot of experiments that seem to verify all these rules. But we didn't do any formal proofs to prove all of this stuff. You know, this proof that they would have you do today would tend to prove all of these points. But we're not going to bother with that. That's high school or maybe even college level math, in my opinion. And I'm just not going to do that. I can do it in a 20-minute video, again, if someone wants me to. Just simply ask and say, my teacher needs this. My teacher can't explain it very well. And I will do my best to explain it to you. Otherwise, we're going to move along. Now, the thing that we're going to do now is we're going to learn how to graph using intercepts. This is one thing that we haven't really done. We've kind of done it, but I'm going to explain to you exactly how you do this process and when it might be useful, which is good candidates for this method. Okay, so graphing using intercepts. Let's just kind of highlight it like that. So the idea, and then we're going to make a graph here, so we can actually do this, and I'll show it to you. You make a graph, and notice that the thing to notice is that any line will eventually exhibit that is not. Here's the idea. Any line that is not vertical or horizontal will cross the x-axis and also the y-axis. That's key. Any line that is non-vertical or horizontal will eventually cross both of these axes. And let's see why. So if I took a line that's like this line, this line will eventually, these arrows mean it goes on forever, it'll eventually cross the y-intercept somewhere around here, and it will cross the x-axis somewhere around here. Somewhere around here and somewhere around here. Okay? Let's take a different line. I'll leave all these lines up here. Let's take this line here. Let's make this really steep. So this is non-vertical and non-horizontal. This line crosses the x-axis right here, and we'll cross the y-axis somewhere down here. Okay, just think about this. We'll just do another line. We'll do this one in green. So if we take this line right here, non-vertical, it will cross, you know, that keeps going forever in this direction. It'll never cross an x or a y-axis in this direction, but in this direction, it will cross the y-axis probably right about here, and it'll cross the x-axis right about here. Okay, so any line that is not straight up and down, like this straight up and down line here, will never cross the x-axis. It'll cross the, sorry, it'll never cross the y-axis. Again, this is the y-axis and this is the x-axis. Maybe I should have drawn these things as x's and y's. This could have been drawn as a y, and this could have been drawn as a y, And this could have been drawn as a y, so it doesn't confuse you. Okay, but this lines that's straight vertical will only cross the x-axis, but it won't cross the y-axis. And lines that are horizontal will never cross the x-axis, but will cross the y-axis. Okay. So, but again, if it's not vertical and not horizontal, it will cross both axes. Okay, so let's get rid of these guys. I think we have a good intuition, a good understanding of that that's true. So the way that we do this, we need to find the intercepts. So the intercepts are those two places where they cross. And notice if I find two places where a line crosses the x-axis and the one place where it crosses the y-axis, I can then draw a line and I will have my line. So this is another method of graphing a linear equation. So let's look at this guy. How can we figure out, the question is how to find the x and y intercept. Again, this is called the y-intercept because this is where the line crosses the y-axis, and this is called the x-intercept because it's where the line crosses the x-axis. Okay, let's get rid of this guy. Let's get rid of these words, and let's see if we can find these x and y intercepts. Now, again, the y-intercept is on the y-axis, and so what is true of every point on the y-axis? What is true is that it has an x value of 0. Let's notice, here we have 0, 2. Here we have 0, 5. Here we have 0, -3. What's true is that any point on the y-axis has an x value of 0. So I can make a chart and I can say, well, when x is 0, find my y, and this will be my y-intercept. We'll do this process here in a little bit. Similarly, if I'm on the x-axis and I go to 3, 0, or 1, 5, 6, 7, 8, 9, 10, or if I go to 10, 0, what's true about all of these points? I think you see it. And what's true of any point that's on the x-axis, you have a y value of 0. So I need to find the y value of 0. What is x when y is 0? And this will always be my x-intercept. Okay, so how do we do this? Well, to find my x value of 0, but what y is when x is 0, I simply plug x equals 0 into equation. So let's do that. So we say to find my y-intercept, I plug 0 for x, and I go 2 times 0 minus 5y equals 10. Well, 2 times 0 is 0, so minus 5y equals 10. So y equals -2. When x is 0, y is -2. Likewise, to find my x-intercept, I put a 0 in for y. So 2x minus 5 times 0 equals 10. So 2x equals 10. So x equals 5 when y equals 0. So I have my y-intercept of 0, -2, and my x-intercept of 5, 0. So let's plot that in, say, red. So here we go. Here's 5, 0. And my y-intercept is 0, -2. And so these 2 points are on a line. So to create my line, I simply do this. And there is my line. I find the line that goes through these 2 points. Okay, so what are some good candidates for this method? So there's 2 things that have to be, one thing that must be true, and that's A, we have to have an x and y must have non-zero coefficients. Right? Because if x or y had a 0 coefficient, let's look at that for a second. So if I had, 2x plus 0y equals 10, I would have the formula that simplifies to 2x equals 10, and that would be x equals 5. And we know that this is a vertical line, and we can't have vertical lines. So if x or y has a 0 coefficient, then we have horizontal or vertical lines, and we do not have a line that crosses both axes. So that's the first thing. Most lines will have a non-zero coefficient for both x and y, so we're good. The second thing that we want to be true, that's A. The second thing that we want to be true is that we have easy divisors, so that we have this value C, this constant, the constant can be evenly divided by the coefficients for x of x and y. It's not required, but it's nice. So notice if because 10 can be divided by 2 and 10 can be divided by -5, I end up getting integer values for the coordinates of my line. We do an example later where this isn't true, where the constants can't be evenly divided. You can still use it you can still graph if this isn't true, but you'll see that my intercepts will be fractions. Okay, so all we do, again, what's the key? What are the key steps? Is we find the value of y when x is 0 and the value of y and the value of x when y is 0. We plot those 2 points, and then we've graphed using intercepts. We're going to do that 2 more times. Here we go. So we're going to graph using intercepts. This one is going to have whole numbers or integers. This will have integer coordinates for the intercepts. And this one will not. Will not have integer coordinates. But we'll show you how we do it, and it still will work. So we can do it we can use this method, we can graph using intercepts for both of these equations because they're not horizontal or vertical lines, because x and y both have coefficients. Okay, so you can pause and try if you like, or you can just maybe wait. We can do one together, and then you can pause and try on the second one. So all we're going to do is we're going to make our graph or our little chart of x and y. We're going to find 2 points. One when x is 0 and one when y is 0. Okay. When x is 0, 3 times 0 plus 6y equals 12. So this is cancels. 6y equals 12. So y equals 2. So x equals 0, y is 2. And then when y is 0, we get 3x plus 6 times 0 equals 12. So 3x equals 12, x equals 4, and that's when y equals 0. So to graph this guy, we go to 0, 2. And here we got 4, 0. And then we're simply going to make our line. There you have it. We have graphed using intercepts, lay down the happy cat. We'll do this other one in green just because I like changing it up. Okay, so this isn't going to have even coordinates, but watch how it's still going to work out. Okay, x, y. We got to find y when x is 0 and x when, x when y is 0. So we're going to say, well, 2 times 0 plus 3y equals 7. 3y equals 7. Y equals 7 over 3. So when x is 0, y is 7/3. Or 2 1/3. Same thing. And when y is 0, we get 2x plus 3 times 0 equals 7. 2x equals 7. X equals 7/2. So x is 7/2, which is the same thing as 3.5. Okay, so we have our points 0, 2 1/3, and then 3.5, 0. So these 2 points are on our line. So 0, 2 1/3. So 2 1/3 is right about, oh, who knows? It's about right here. Because that right there is 2.5. So 2 1/3. And here's 3.5, 0. Right here. And we make our line. I'll label that point. So it's not the best, but it still works. That's still a valid graph. I don't like graphing variables, or sorry, graphing fractions, I should say, but it still works. Okay, so what we're going to do now is we're going to move along and we're going to go into homework help. This is our homework help section, and we are going to graph some lines using various methods. I didn't actually write this one on here, so we're going to put our equation that we're graphing here. Yeah, let's do that. I'm going to extend this line here a little bit because I know I'm going to need it. All right, so we're going to graph this. We're going to graph this 2 ways. We're going to graph it using intercepts over here, and then we're going to graph it using y equals mx plus b form. So we got to use our last lesson, what we learned in the last lesson, to graph this one here in y equals mx plus b, and then we're going to graph it as intercepts over here. And we're going to see that it's the same line, because it better be. Then we're going to graph this line here, and then we're going to do some other graphs to complete our homework help. So now I want you to pause and try. Again, hint here, y equals mx plus b. Put this in y equals mx plus b form. It is not in y equals mx plus b form, so it's hard to graph it right now. Okay, so I assume you're back. Let's do this using intercepts. So first of all, we'll say we have to find our x and our y, our x when y is 0 and our y when x is 0. So let's do that. So 6 times 0 plus 2y equals negative 18. So 2y equals negative 18. So y equals negative 9. So we have x is 0 and negative 9. Then when y is 0, we have 6x plus 2 times 0 equals negative 18. 6x equals negative 18. X equals negative 3. So let's graph those 2 points. Negative 3, 1, 2. So that's negative 3 comma 0. And then 9, 1, 0 comma negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 comma negative 9. And we have our line where it crosses both axes, our 2 intercepts, in other words. And there you have it. Now, let's graph it the other way. Let's graph this using y equals mx plus b form. You know what I'm going to do? I can actually detect I'm going to have a problem here. So I'm going to take this line, and I'm just going to shift it up. Like this. Okay, you'll see why I did that here in a second. It's because my graphs, I didn't really make them big enough. Okay, so let's do this. So we have 2y equals negative 6x minus 18. Because I subtracted 6x from both sides, now I divide everything by all my terms by 2, and I get y equals negative 3x minus 9. So my slope is negative 3, or negative 3 over 1, and my y-intercept is negative 9. So I have to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's my 0 comma negative 9. Now my slope, I rise negative 3 and I run 1. So that's 1, 2, 3, 1. 1, 2, 3, 2. And now I can make my line. Again, remember I did a lot of this in the last lesson. If you forget how to graph using y equals mx plus b form, I did it a lot in lesson 18. So notice we cross the axis at negative 0, negative 9. We cross this one at 1, 2, 3, negative 3 comma 0. Just like we did over here. So these are in fact the same, these are the same. So you can make a decision for yourself whether graphing using intercepts or graphing using y equals mx plus b form is easier for you. Now on this next one, we don't want to be messing with graphing and using intercepts on this next one because we have fractions and stuff. So let's just use our y equals mx plus b form to solve this one, and we'll go y equals negative 2/3 x plus 8. If you want to graph this using intercepts, you can, but you're going to end up dealing with some interesting fraction work, and I just would choose not to do that. So here our slope is negative 2/3, and our y-intercept is 8. So we go 0 comma 8. And then we rise 2, which is going down 2. Uh-oh, we're locked up a little bit here. Down 2 over 3. Down 2 over 3. Down 2 over 3. Down 2 over 3. And we can draw our line. We only needed to do 2 points, but I like to do more points just because it makes it easier to just line that graph up and not make any mistakes. It's really easy. Down 2 over 3, down 2 over 3, down 2 over 3, down 2. You just keep making points, and it will always be in a straight line if you do that. Okay. Happy cat, happy cat, happy cat. Homework help number 5 is, or here we go. I just want to remind you that the point here is that these are horizontal. These two guys here are horizontal and vertical lines. And I want to just kind of remind you which is which. And if you remember, the rule is for these lines that don't have an X or a Y in them, they only have X or Y, but not both, you're going to end up either vertical or horizontal. And the way to remember it is, you know, if it's X, then it crosses X axis at that intercept, at the given intercept. Okay, so all right, so here's our x-axis. This is a -2, so I just go on my x-axis to -2. You know, -2 comma 0, and then I draw my line, and I draw a horizontal line here because I don't draw it straight on the axis. I just draw it like this, right? It crosses. Another way to do it is you can make yourself a t-chart. You can say, well, it's true that x is always -2. So when y is 0, x is -2. When y is 1, x is -2. When y is, 5, x is -2. So I get these points: -2, 0, -2, 1, -2, 5. And you can see that's a horizontal line. So you can go with the t-chart method, or you can go with kind of the cheat method. And here, if x equals -2 is a vertical line, then y is 6 is a horizontal line. But how can I know that? I know that it crosses y-axis at 6. So let's see. Here's my y-axis. I go up to 6, and we cross it. So to cross it, we have to go this way, and that's y equals 6. Okay. All right. Now, number 3 is kind of a teaser. So do we know how to graph this? And why do we maybe not? Maybe the answer is why not? I'm kind of giving you the hint that this may be hard to graph, or we don't know how to graph it. So think about it, pause, think about it, and then I'll come back and I'll tell you the answer. Okay, so I assume you've paused and tried. So the answer is we have this problem here. This exponent is a 2. So this is not a line. So we don't know how to graph it. And there we have it. There we have lesson 19. Lesson 19, the graph of a linear equation is in two variables is a line. We didn't do the proof. If you need me to do the proof, remind me or tell me to do it, or tell me you need me to do it, and I will do it. But otherwise, I think it's something that is beyond what 99% of 8th graders need to know. I'll try to explain it, try to prove it, or can prove it, but it's not a standard. In fact, it's not a standard for 8th graders. So that is definitely the case, that you do not need to know how to do this to be considered proficient in Common Core for 8th grade. So they know that's true. At any rate, we learned how to graph using intercepts, And then we reminded ourselves 3 other ways of graphing, one by putting things in y equals mx plus b form. And then the final kind of graphing is when we have horizontal or vertical lines, which are x equals some number or y equals some number. All right, good job. Whoops. I meant to do that one. Thank you. We'll see you with lesson 20 or 20, whatever, next time. Over and out.